oil imports. Daily crude oil imports to the United States from Mexico for 2009 to 2013 could be approximated by the function I of t equals negative 39t squared plus 800t minus 3000 in 1,000 barrels for t between 9 and 13, where t is the time in years since the start of 2000. Find the derivative function di over dt. This is the Leibniz notation. At what rate were oil imports changing at the start of 2012? Corresponding t equal 12 because t is the number of years since 2000. First, we will need to find the derivative function, not just the derivative at any point, but the derivative function itself. Given that I of t equals this formula, the derivative function is di dt, which is simply I prime of t in the prime notation. These notation can be used interchangeably. In word problems, usually we use the Leibniz notation, d over dt. This is, by definition, the limit at h go to 0 of I of t plus h minus I of t over h. To evaluate this limit, we need to know what I of t plus h is. I of t plus h has the input t plus h, and so we would go to the given function and we replace t with t plus h. Everything else is the same. Negative 39, t is now t plus h squared plus 800, t is now t plus h, and then minus 3000. This is the term I of t plus h. We also need to know what I of t is, but I of t is given, which is negative 39t squared plus 800t minus 3000. With the first term, I of t plus h, we will need to expand and simplify. I of t plus h is negative 39, t plus h, the quantity squared is t squared plus 2th plus h squared. And then we distribute 800t plus 800h, and then minus 3000. Simplifying this, we have negative 39t squared minus 39 times 2 is 78, and then we still have th minus 39h squared plus 800t plus 800h minus 3000. We then attempt to combine like terms, but there is only one term with t squared, there's only one term with th, there's only one term with h squared, there's only one term with t, and there's only one term with h, and there's only one term with the constant, and so we would keep everything, and we cannot combine anything else. We then put these back into the limit formula. This is the limit at h go to 0. We replace I of t plus h with negative 39t squared minus 78th minus 39h squared plus 800t plus 800h minus 3000. And then we replace I of t with negative 39t squared plus 800t minus 3000, and we need to put this in the bracket because everything in this bracket have to be subtracted from this whole expressions here over h. And then we will attempt to simplify the numerator first. Negative 39t squared with a plus 39t squared. Or we can think of this as negative 39t squared minus the same thing. So they cancel out. Similarly, 800t minus 800t canceled out. And lastly, negative 3000 minus the same thing, negative 3000. And again, if we were to do this correctly, we should be able to cancel everything in this bracket. And so this is why oftentimes with this type of problems, we put this second term inside the bracket, because there is a good chance that we will be able to cancel them all out. We then factor out the numerator after we cannot simplify this further. In the numerator, we only factor out h. We have h times the quantity negative 78t minus 39h plus 800 over h, and for the purpose of canceling out h. This will give us the limits at h equal to 0 of negative 38t minus 39h plus 800. We then evaluate the limit. The term negative 78t does not have h, so it stays. Negative 39 times h, but at h equal to 0, the term goes to 0, because negative 39 times 0 is 0. The term 800 stays. And so this is, without the limit notation now, negative 78t plus 800. And this is the derivative function. We write this as di over dt equals negative 78t plus 800. And this is the derivative function. Next, the question asks us to find at what rate is the derivative. At what rate were oil import changing at the start of 2012? And so we would evaluate this derivative at the year 2012, or when t equals 12. Remember that t is the number of years since the start of 2000. So 2012, t equals 12. We simply plugged in 12 into the derivative, not the function, because we're looking for the rate. Computing this, we have negative 136. The unit for this derivative is the unit of I, which is in 1,000 barrels. And the unit for the denominator, t, is year. To interpret this, we would say at the start of 2012. This is very important. It is important that we mention the time, because derivative, this rate is only good for this specific year. And so that is why we would need to mention it. Oil imports. In this case, since the rate or derivative is negative, we would use the term decreased by, but if we use the term decrease already, we no need to include the negative sign. By 136,000 barrels per year. What this means is that starting 2012, the imports would go down by 136,000 barrels each year.